Okay, so can you hear me? Hello.
Hi, yes, perfect.
Yeah, so how are you?
I'm fine. Unfortunately, I have not performed the homework
Oh,
because I wasn't well during the week, but I'm working on it and I will send you if you are
okay,
agree
no
in
problem, no
the next
problem.
days.
Okay, so when you get the time, you can also try to do that. So mainly this
Yeah.
homework is for your practice session. Okay, so when you face any problem, then we also easily contact with this. Okay, for the find out the
Okay.
solution about that. Okay, so
Okay.
basically we will start our for the today's our fourth number of class. And so basically today we will try to discuss about the some advanced topic on remote sensing, and also try to show you that practical example all of those topic,
Okay.
how we can easily implement the different types of remotely sense analysis for the art observation using the advanced remote sensing technique. Okay. Okay, so
Okay.
let's go our today's class. So I simply share my screen. Okay. Okay, so now can you see my screen?
Yes.
Okay, so let's go. Okay, so okay, it's loading. Okay, so hi and welcome to the 7 days online training program on Google Earth Engine for remote sensing analysis. And we already cover our first day, second day, and third day. So basically, today is our fourth number of class. Okay, and this course content today mainly I will try to discuss about that how we can easily remove the cloud from the satellite imagery, such as Landsat or Sentinel, both of satellite imagery, how you can easily remove the cloud and get the clear satellite imagery, as well as we also try to discuss about that visualization of DEM data. So mainly visualization of DEM data means that how we can easily visualize the hill shape map using the DEM data, how we can easily visualize the salt map using the DEM data, as well as also aspect map, and what's the application of the hill shape map, what's the application of the salt map, what's the application of the aspect map. We also try to discuss about that, and we also try to discuss about the land surface temperature monitoring from MODIS satellite imagery, and also make the time series chart. And previous class we also try to discuss about the land surface temperature monitoring using the Landsat imagery. And today's class we also try to discuss about that land surface temperature monitoring using the MODIS satellite imagery, as well as we also try to discuss about that how we can easily calculate the average, maximum, minimum NDVI, mainly normalized difference vegetation index for any specific region, how we can easily calculate the average, maximum, minimum NDVI for any specific regions, or suppose any specific agriculture land you want to identify what is the average NDVI, what is the maximum NDVI, what is the minimum NDVI. Okay, for any specific region. Okay, so let's go over today's class. First of all, I will try to discuss about that how to calculate average, maximum, minimum NDVI for any specific region. And previous class we also try to discuss about the time series chart, how you can easily create the different types of time series chart, such as when you want to work with the Landsat image, and also make the time series chart when you want to work for the ready-made data set, how we can easily calculate the time series chart. So this type of analysis we already covered. So basically today I will try to show you that how we can easily calculate the value. But what is the average value of NDVI, what is the maximum value of NDVI, what is the minimum value of the NDVI for any specific region, how we can easily calculate this type of value. So let's go about that. I simply open my code editor and also open a code editor about that. Okay, I open a new code editor. Okay, so let's go. Winning, yeah. Okay, so when you calculated the NDVI, so first of all we need to calculate the NDVI. First of all, we need to calculate the NDVI. Suppose for any specific region, I want to calculate the NDVI. So suppose I simply suppose so I want to work for the Dhaka city region, and for the Dhaka city region, I want to find out about that what is the average, what is the maximum, what is the minimum NDVI. So first of all, I simply input my shapefile of Dhaka city region and put this name, suppose ROI. Okay. After that, I simply display the result. So user add layer with ROI, and also focus, center focus of this map. So user the map dot center object and call the ROI, zoom level suppose 10, and click to the run. So now it's focusing my area. So this is my boundary, or this is my area. Okay, so for this area I want to calculate the NDVI. Okay, so let's go about that. In this time I want to work with for the suppose Landsat image or Sentinel image. So I want to work with for suppose Sentinel image. For get the high resolution image, I want to use the Sentinel. If you want, you can also use the Landsat. There is no problem. Both of is the same process. So I simply click on the Sentinel, and I want to work with for the Sentinel to multispectral instrument. After that, I want to work with for the Sentinel top of atmospheric images. In this time, I want to use it, and I want to I can see the all of the information about this image. Just I simply copy this image from here, and after that, I simply paste. Okay, and give a variable name, suppose S2 or Sentinel2. Okay, so now this image collection I need to filter. So suppose I want to use that take a variable and put the variable suppose image and call the S2. First of all, use the filter bounds function. So it's already discussed about all of the things about the function for filtering. So I use the filter bounds and use the suppose. After that, use the filter metadata and put here this. You can simply go to the properties. Suppose you can see the image properties, cloud pixel as in cloud pixel percentage, and then select here and put the cloud pixel percentage such as less than suppose 1. Okay. After that, I simply put at the specific time period. So for that, use the filter date function. Okay, so put at this time period, suppose year of 2020, 1st January from year of 2020, December 31. Okay, so now all of those images I want to make the median composite. So use the median and then clip with my shapefile. So use the clip with my shapefile is that RY. Okay, so now display the result. So use the map dot add layer and call the image. So now one image will be added, year of 2020. Okay, this image is the added, you can see. So I can get total 1 year all of those images and make this composite, and I want to display the result. For that, I simply click on here again and put here the such as before red, then green, and then blue. Okay, custom stress 98% and apply it, and also import this visualization. Okay, so simply copy this visualization from here and paste after the object name. Object is the image, simply paste after the object and put this name, suppose true color. Okay, so now it will be set with that. So I got my image. Okay, in this time I got my image. So now I am using this image, and then try to calculate it, the NDVI or vegetation index. I need to calculate it. Okay, so first of all, I need to make the NDVI map for this region. And what is the NDVI formula? We already know about NDVI formula is that NDVI formula. I write the formula. Suppose it is that near infrared minus red divided by near infrared plus red. So this is our formula. Okay, so now I implement this formula in here and try to calculate the NDVI. And you already know about that, lot of process, lot of method we already discussed our previous class for calculating the different types of indices or different types of equation, how we can easily calculate it. This part we already covered. Okay, in this time I simply use an easiest way for normalized difference function I use. So take a variable, suppose NDVI, and call this image and use a function normalize difference and put the band only for the B5 is the near infrared, and then also put here the another thing is that B4. Okay, so now it created the NDVI. I simply put here this add a layer, suppose map dot add layer, and show the NDVI layer, NDVI, click to the run. So now it displays the NDVI map. You can see I create the NDVI map, and from this NDVI map we calculated what's the average NDVI for this region year of 2020, what is the maximum NDVI for this region year of 2020, what is the minimum NDVI of this region year of 2020. Okay, so now you can see this map is look like that. So I want to add the visualization, that is also better. So for that I can simply make a visualization parameter in here. So I use at the curly bracket and put at the mean. It will be start from the -1 and then max up to +1, and then make the related function of the color. I need to show the blue color as a water body, then white color such as the built up area or barren land, and greenness or vegetation I want to show as a green color. So now this color is set with my map, and now it displays the result of the NDVI. From this map we can easily identify where is the NDVI is high, where is the NDVI is low. We can easily find out from this map. You can see.
Yes.
Okay, it loaded. You can see this image I use and make the NDVI map. From this satellite images I just extract the information of vegetation. Okay, you can see we get the result look like that. And this result you can see, okay, you can see some vegetation we can got in here, and other drop all of the area we can get as a white color, green pixel value, white color. White color means that there is the no vegetation. It can be built up area or also it can be a barren land. Okay, so in this time we can get the some vegetation in this region. So it also better understand when I also increasing the value of this 0.1. In this time you can see I put the max value 1. But for this region, max value of 1 NDVI is not available. Okay, because this region is not a forest. This region is not a dense vegetation. Okay, mainly high positive value identify the dense forest or highly dense forest, high positive value. So I simply put here the suppose if you want to check the value about that inspector and click the any vegetation value. Suppose I want to check what is the pixel value of this NDVI. We can get the value almost, you can see 0.24. Okay, for the vegetation. So it also it means that it also vegetation is available but not densely. This vegetation is not dense vegetation. You can see very low positive value 0.2. So if we want to check the another region, suppose for the green pixel value, suppose you can see we can get the some green pixel value in here. So very low vegetation we can get 0.009. Okay, so it almost 0 or almost less than 0. Okay, so because it not a high density of the vegetation, in this time I also increasing the value, then I also get the better result. Okay, because in this time all of those green pixel value is lower than 1, lower than very 1. Okay, less than very 1. So in this time I can simply put here the suppose 0.5, then I also get the better understand about the vegetation, because for this region 0.5 is closer to this vegetation pixel value. Okay, but 0.1 but the range of the -1 to +1. In this time we can get also the vegetation. You can see some vegetation is also increasing in here. Also we can get the better about that. Okay, so you can see in this time we can get the some densely vegetation as a vegetation. You can see, click on here and check the value. Suppose I put the value 0.19. Okay, almost 0.2. Suppose I want to use here the suppose 0.3 and then check what is the result we can got. Or also put here the 0. Okay, in this time when I put the 0, I can get the result between these range 0 to 0.3. All of those pixel value display on this map. Okay, you can see I can get the result look like that. Okay, 0 to 0.3. Suppose I want to put here this -1 and 0.3. So now I can get the result within this range of this image visualization showing within this range. Okay, so I want to put here the suppose 0.8. Then I can get the result within this range of this NDVI index of NDVI. Okay, so if you want, I also use here the some more color. Suppose I want to put here the another color. Suppose yellow, I want to use here the yellow color. Then check what the result you can get. You can see simply put. You can use the different color. There is no problem. Okay, you can see I can get the look like that. Okay, so it's not better for the yellow color. I simply remove that. In this time, click to the run. Okay, so we can get the vegetation map. Very less vegetation, only some area is the vegetation, other thing is that the build up area. So this is our vegetation we can got in here. So in this time, from this area I want to calculate suppose average NDVI. I want to calculate suppose maximum NDVI. I want to calculate suppose minimum NDVI. All of this parameter I want to calculate in here, or standard deviation of this NDVI. So all of this I want to calculate it. Or if you want, you can also export this map. Okay, suppose exporting is the same process. Use there the export. Okay, before that we calculated the average value. Okay, for calculating the average value, we use a function. This function called that reduce region. Okay, it's function. This function we are using. So for that, I simply take a variable. Suppose I put the variable name is that average, and then I simply call this NDVI, because from this NDVI I want to calculate the average. So call the NDVI and use that the reduce region function. After that, I simply put all of those argument one by one, and then make a dictionary, curly bracket start, and also curly bracket in here. Okay, and first of all reducer. So reducer is a statistical function. In this time, you want to calculate the average, you want to calculate the minimum, you want to calculate the maximum. I want to calculate the suppose average. So user ee dot reducer dot mean. Okay, then geometry, I simply put the geometry such as our RY. Then scale is that only for the 10 meter scale, and other thing not need. I simply remove that, it's not need. Okay, so now I just simply print that result. So print this average result, click to the run. In this time it display the result about that our what is the average NDVI for this region. It calculated. You can see, you can check what is the value you can get in here for this region. What is the average NDVI in year of 2020. So here you can see you can get the average NDVI is the 0.03, very less. Okay, and if you want to check the maximum NDVI for this region, what can we do? Just I simply use the same code, simply copy that and paste again. Just I simply put the name, suppose it's the maximum or max. I put that max and also change it as a max. Okay, and also print that max value. So print the max and click to the run. So in this time it also showing about that max result. You can see it calculated.
Yes, perfectly. Yeah.
Okay. So in this time, suppose in year of 2020, what is that maximum NDVI for the region? You can get the 0.27. Okay, and this is our average result 0.03. In this time, suppose I want to show the result for minimum. Use the same code. Simply copy that and paste it again. In this time, I simply change it. Suppose I put the variable name is the mean, and also put here this mean, and also put here this print this mean result. Now click to the run. So now you can easily get the result about the mean or minimum pixel value of NDVI. Okay, it calculated. You can see I simply click on here again. We can get the minimum NDVI is the negative 0.19. Okay, this is the minimum. If you want to check the standard deviation, simply copy that and paste here. And suppose put here the STD standard deviation and use here the STDE. Okay, then also copy that variable name and paste and click to the run. Okay, it's the, you can see the standard deviation. You can see this is the standard deviation value. Okay, and mainly standard deviation value is that mainly it's defined how dispersed the mean, how dispersed the data is in the relation to the average value. Okay, we can also calculate the standard deviation, mainly it's showing that 0.04, and these are mean value. Okay, mean value, how data is the dispersed set from the mean value, it's showing that standard deviation. Okay, so standard deviation is that we already know about that. Suppose if you want to check the some Google, you can easily idea about the standard deviation, or you can also follow my YouTube channel. Here I already discussed about the standard deviation, all of the statistical part, how it will be work. So I also show you this. You can simply, okay, I also show you that. So you can simply go to this YouTube, and also I already discussed about all of this formula, how it will be work, and what is the meaning of the standard deviation, what's the result I can got from the standard deviation. All of those things we also try to discuss in this playlist. You also try to check it. Then I hope you can easily understand about that. What's the product you want to get after applying the standard deviation? This type of work you can easily get from here. So I simply open. And go to the playlist. Okay, so it's machine learning. Here we already discussed about all of this part. So I also send you the
Okay.
link. So you also try to discuss about that all of this part for the what is the mean mode, what's the value you can get for the mean mode, also standard deviation, percentile, and also NDVI LST linear relationship and predict the LST. So you also try to discuss or learn about these things. Then you can also get the lot of information about the all of the statistical part of the in Google Earth Engine platform. I also send you the link in here. You can also save it and try to follow that. Then you can also get the easily idea about the standard deviation and how it will be work. Okay, what's the value mainly it provide. So this type of result you can easily get. Okay, so basically in this time we can get the value for the mean, then median, then we can get the value minimum, maximum, average, and standard deviation. If you want, we can also get calculated the median value. Just simply put here the median, e reducer dot median, Okay, this is the median result you can get. Suppose you want to use at the mode value, simply use at the mode. Okay, or if you want any value, you can easily calculate it using the same process. And what's the meaning of this type, the different types of statistical term, you can easily get the idea from this lesson. Okay, so this is the process for calculating the NDVI, as well as also calculating all of the things. If you want, you can see this time we want to use at the sentinel image. Suppose you want to use at the Landsat image, what can you do? Just simply change the image collection. Suppose here you can see in this time I want to work with the Landsat, so simply click on the Landsat imagery again, and suppose I want to work with for the Landsat 8 image collection, and I want to suppose top of atmospheric of the Landsat 8. And then simply copy this image collection and paste here. Paste here, and also change this properties name, because cloud pixel properties is for sentinel, but in this time it will be cloud cover. Okay, cloud cover is the properties of Landsat. So now click to the run. In this time I can get the result about that NDVI. Okay, we can get the result properties. You can see we can get the result. And previous time we also mistake in here. This mistake is that we mentioned the wrong band. Okay, because Sentinel-2 satellite imagery near infrared band is the B8 for the Sentinel. Okay, but Landsat is the B5. When using here the Sentinel, then we have to use here the B8. Okay, so B8 is for near infrared band. If you want to check it, you can see in this time you can see band 5 is that, you can see band near infrared is the band 5. There is no problem. But if you want to check the value for the Sentinel, what is the near infrared band value? We can get the near infrared band is that B8. Okay, so this is another problem when we can use that. You can see the band from here. We can get the band for the B8. So B8 is that near infrared band, INR. INR is the B8. Okay, so that's why first time we did not get the proper result. In this time it's showing the proper result. It also showing the proper result. You can see, suppose I want to use here the Sentinel. So I use here the Sentinel, and then I simply change the band. I put the band name, suppose such as in this time B8. B8 is the near infrared and B4 is the red band. Okay, so now we can get the better result of the NDVI. Okay, NDVI is the mainly near infrared and red infrared band we must be need. Otherwise it's not showing the good result, or we did not mention the equation. Okay, we did not get the NDVI map. In this time you can see it's showing the very well, and from this map we can easily identify the water body. All of those things we can easily get, as well as we can also identify the all of those value. Okay, you can see we can easily identify this is the vegetation region. Okay, this map is the better. Okay, first time I put for my mistake I put at the B5. Okay, B5 is the near infrared band for Landsat, but B8 is near infrared band for Sentinel. Okay, just also remember that and we'll put the equation, then you can get the very better map of the NDVI. You can see, okay, it's showing the NDVI map of this. We can easily get that, and also calculated for this region what is that maximum minimum standard deviation NDVI of this region. You can easily calculate it. Okay, you can see for that this is the average NDVI 0.1, this is the maximum NDVI 0.6, this is a minimum NDVI 0.1, and this is that standard deviation 0.13. Okay, so this result you can easily get from here. And if you want to check the value, suppose click on this and click on the water body. For the water body you can get the negative pixel value result. You can see the negative, and it's showing the ND. It default showing the ND, but we are also change the name. For that we can simply put here the rename function. Let's just put here the rename. So put here the rename and put this name, suppose NDVI. So now it will be showing as the NDVI result. You can see we can get the NDVI 0.6. Okay, average NDVI, this is the average NDVI. Also you can see maximum NDVI, Also you can see minimum NDVI, and also you can see the standard deviation NDVI. Okay, so using this code you can easily calculate for any region, for any agricultural land or anything. Just you can simply draw your region and then calculate or find out what is the average NDVI, what is the maximum NDVI, what is the standard deviation NDVI. All of those terms we can easily calculate it for the any time period. Just simply put this time period and calculate that. And mainly in this time we just talk about the reduce region function. So reduce region is a function. It mainly calculated for any specific statistical part. Suppose minimum, maximum, standard deviation, then we need to use the reduce region function. Okay, and for the sentinel, our near infrared band will be B8, and for the Landsat near infrared band will be B5. Okay, so this type of work we can easily calculate from here. And finally we can also download this map. Okay, we can also download this map and also make the further work in ArcMap software. So let's go about that. I also try to discuss about that how we can easily create this type of map. So I simply open my ArcMap software also from here, and also try to show you that how you can easily make for the beautiful or research paper map. Suppose this map you want to download from here and use the ArcMap software for calculating your research paper map or your presentation work map. Okay, so it opening. Okay, it's opening. And you can see sentinel is the high resolution imagery, so that's how you can easily get the very good quality map. Okay, and it's easily showing all of those feature, all of those build up area, all of those water body, all of those vegetation. We can also get the result for the high resolution and easily calculate this type of result from here. Okay, so this is the water body, you can see. Okay, water body, and this is the vegetation. Also you can see vegetation. Okay, this is the water body, white color, you can see.
Sorry, just a question.
Yeah,
you
please.
told me that in case I will see the YouTube channel, I can also see some videos that a normal user cannot see. I can display in the normal dashboard or in, because I have checked it but not found probably.
Okay, so in this time which video you want to need, you can also mention me. I also give you the access, privately access, then it also better.
Okay.
So because
I have only to request to you. Okay,
you can also just mention me. So because in this time we are also provide some also advanced level of this tutorial is not publicly available, but some part is also available for the publicly. So if you need any advanced things or advanced thought and which is available for me, then I definitely share with you. There is no problem.
Okay, thank you so much.
Okay, so let's go about that.